shield, there's actually one more piece of shield that goes in here. It's called the tail shield. That's what's sitting out in the yard there. This is the area where the tunnel lining is actually erected. So this device right here is called the segment erector. So it takes those precast concrete segments that are sitting out in the yard there, and it uses a vacuum to pick them up. This area right here, a vacuum is created in there. So it pushes down onto the segment, and then you suck the vacuum and you can pull, pick the pieces up at that point. And then this device, the segment erector, rotates around, sets the pieces of concrete in a full ring. So the rings are 5 feet long. So basically an excavation sequence is cutter head turns and the machine pushes forward 5 feet. Once it's done that, you stop mining. The concrete segments come in, pick up the segments, and then arrange them in place. There's 6 segments that make one ring. Set them in place, bolt them in place, and then push the hydraulic jacks up against the segments again, and then push forward again. So it's kind of like a little tunnel factory. You do the same thing kind of over and over and over again. So a sequence of what I just described you generally basically takes about an hour or so. So mining, erecting the segment, and then getting ready to mine.
How many segments in the full circle? 6.
Yeah.
They're bolted together?
Yeah, that's how do they stay together? How does a 6-segment segment stay together with the next segment?
When we're constructing, when we're building them, they're bolted together. Okay. Really, once they're in the ring, once they're all together in a circle, they're stable at that point. You don't really need the bolts anymore. In some tunnels, in fact, you don't even use bolts, but they're kind of a safety measure, and while you're constructing the ring, as well as they kind of help you align everything up nicely. Because the lining that we put in is not, it's the final lining of the tunnel. So when you actually ride through with the trains, you'll see the liners that we put up in the machines. So that, up until, say, the last 5 years, that was not common. It really wasn't done. And now, we figured out how to build segments that are accurate enough that they can meet the final line.
What did you get? Can you get a void when you're boring through the hillside? Is it always perfectly round, or do you get some area where you have sand or something in it?
Well, I would say that that's abnormal, creating voids and collapses. I mean, there's 2 things I can say. You do actually create a little bit of a void because the machine diameter that it cuts is bigger than the outside diameter of the segments. So to deal with that, as the machine moves along, we're actually injecting grout between the segments and the ground. And so that happens, actually, there'll be some ports integral part of the shield that come through the tail shield, and as the machine's moving forward, this grout is automatically being injected. So it's very important that as you mine along, you're injecting that grout. So we have a number of control systems on the machine to make sure that the machine can't move forward unless you're grouting. So then there's also voids like you hear about. Those you prevent by, let's say, vigilant operation of the EPB method. You need to make sure that you're always pushing up against the ground, and then you make sure you know what you've taken out. So that becomes kind of a...
Is this tunnel just narrow straight, or are there curves?
There's horizontal and vertical curves. So you go.
So how do you change the alignment of the machine?
See that shield there? You see there's kind of a break in it where there's some machined unpainted steel right there. That's called an articulation joint. So it's kind of hard to see, but these are the propulsion cylinders, but there's also inside the shield some really big articulation cylinders. So the machine can actually, you can move it any direction you want, up, down, left, right, any kind of iteration of that. So that's how you steer the machine. The curves here are very minor. On transit tunnels, seldom do you have just really abrupt curves. So the steering actually for these tunnels won't be too difficult. Sometimes on sewer tunnels you have real steep curves that are a little more difficult. But I think the smallest radius is about 1,200 foot radius.
So these are going to be parallel tunnels?
Yeah, they'll be, when they're mining, they're almost exactly like this. There's basically a 20-foot pillar, ground pillar, between the spring line and the tunnel. So it's...
And the span regarding 2 of 3, where's the third one? Is that an access to utility tunnel?
No, the third one is for the U-230 contract. So we built a tunnel from University of Washington to Capitol Hill. And there's another contract that builds Capitol Hill Station, and then they finish the tunnels from Capitol Hill to Pine Street. We're not involved in that. That's another contract.
That contract is one machine making 2 trips.
Okay.
But that segment of tunnel is about half as long as this.
Yeah. Okay, so kind of see a little bit better to turn around, but this big tube that's kind of coming out the middle here, that's the casing that's around that screw auger I was showing you before. So the material comes out of the cutter head and goes up through that tube and then follows along the top of we call these gantries or trailing gear, and it goes back about 160 feet, and then it dumps onto a conveyor. So this is where the material is coming out. Very field controlled manner. One other thing of note here is before we move on, there's a bunch of piping, stainless steel piping. Those are decompression chambers or manlocks. So what happens is when these machines are mining, you're mining well below the groundwater table. So we're always either between, say, 60 and 250 feet below the groundwater table. So if you do have to go out and do any work on the cutter head, you have to take the material out of the chamber, and as you're taking it out, fill that area up with compressed air. And the pressure of that air has to match whatever the water pressure is above you. So you're basically diving, but you're not diving in water, you're diving in air. And to get in and out of that, you have to use decompression chambers. So if anybody's been familiar with diving at all, you're regulated by a certain specification as far as how long it takes to decompress. I'm sure you've heard of the bends before, when they built the Brooklyn Bridge, they didn't really understand the physiology, so they just go in under pressure, and the caissons, and it comes straight out, and people would just, they would have terrible disfiguring injuries and deaths, and that's how the world got sick. So here, the technology obviously is much better. So we have tables that say, okay, if you've been in 2 bars of pressure for 3 hours, this is how long you have to sit in the decompression chamber. So that's where all that work is done. People go in, do their work, come back out and sit in those chambers and decompress, and then travel back out.
But is that only necessary if you're in working on the cutter head?
Yes.
So the operators who are back behind the shields and whatnot, control room, they don't have to go in and out of the chamber because they're not under pressure?
Yeah, that's actually a great question. So this technology completely replaces the way that tunnels in soft ground used to be built. The way that they used to be built was at the very beginning of the tunnel, you make a big bulkhead, about a 10-foot thick concrete wall, and you compress the whole tunnel. And so all the miners would go in every day, every shift, and they'd work in compressed air, and they'd have to decompress back out. There's a number of problems with that, health problems with that. Now, instead of having the bulkhead at the tunnel eye, the bulkhead is in the front of the TBM, and it moves along with the TBM. So now all the miners, every day, 99% of the time, they're working in atmospheric conditions. So they don't have to worry about decompression. The only time you have to use that is if you have to go either do an inspection or you have to do any kind of work on the cutter head in front of you. Any questions?